Alright, let's just do the last few examples. I've just realized as I restarted this video that I've actually made a mistake back in part A. What I didn't notice is that x is an element of the natural numbers in set A, and that must mean that it doesn't include -2 and -1 because those aren't natural numbers. So let's just make a correction to this one, and instead the elements of A are going to be just the natural numbers. There we go. And B is fine because yeah, that's still okay. But part C, there's also a mistake because I was still basing it on the wrong A. So let's just redo part C before we solve the remaining examples. Sorry about the mistake. So we're looking for all of the values that are in set A or set B. So let's list these out. So I'll put in all of my A values. That's 0, 1, 2, and 3. And then I'll put in all of the B values that I haven't yet included, and that's -4 and -3. And you notice that I didn't bother to put these into order. Don't worry, that's okay. You'll also notice that the 0 and the 2, which appeared in both of these sets, I only needed to actually write them down once. Alright, let's move on to part D. We need to find out what are all of the elements that are inside set A and at the same time are not in set B. Or maybe a better way of thinking about this is, what are the elements in both set A and the set B not at the same time? Well, here's set A, 0, 1, 2, 3, and here's set B not. What are the elements that are in both at the same time? Looks to me like only the 1 and the 3 appear in both sets simultaneously. Let's move on to part E. I'm trying to find out all of the elements that are in set A not or B, which will just mean that I'll create a set which has got both of those sets of elements together. Let's start by writing down the set A not. So these are going to be all of the elements inside the universe except for the elements inside set A, 0, 1, 2, 3. So let's write down everything else from the universe. -5, -4, -3, -2, -1. Now I won't write down 0, 1, 2, or 3 quite yet because those don't belong to. Oh, there's also a 4, isn't there? 4 is also inside the universe but not inside set A. And now I also have to add on all of the values that are in set B that I haven't yet included. Well, I've already got my -4 and my -3, but I still need to add on my 0 and my 2 as members of set B. There we go. Alright, let's do part F. We're looking for all of the elements that are inside set A, that are not in set A, and at the same time, they are not inside set B. So, you remember that these are the elements inside set A not, right? I'll just underline them because we'll surely use them again. So those are all the elements inside set A not. Of these elements, these 6 numbers, how many of them are at the same time in set B not? So as I compare these two, I can see that the -5 appears in both. Let's see, the -2 appears in both. Let's see, the +4. Oh, whoops, the -1 I almost missed appears in both, as well as the +4. So these are the 4 elements that appear in both A not and inside set B not. Let's move on to part G. Now I'm looking for everything that is not in A union B. Well, I already know the stuff that is inside A union B. It's this set here. So I want to find the stuff that is not part of this set. In other words, I'm just going to remove this stuff from the universe. I'll write down everything in the universe except for these A union B values, because I'm looking for the complement, everything else. So that's negative 5. Alright, here's my negative 4, negative 3. I've got to take those out. Negative 2, negative 1. Here's 0, 1, 2, 3. I've got to take those out. I'm left with just my 4. You might notice that the answer to part F and the answer to part G are the exact same. And I'll just make a little quick side note about that. There's a reason for this. If you look at part G, A union B not, you might remember a little property that we used to do in algebra called the distributive property. And so if we wanted to apply this not to both the A and to the B, that's fine as long as you remember to flip upside down the sign in the middle. This is called De Morgan's law. In fact, there's another De Morgan's law which is very similar, except it starts with the opposite symbol. So if we wanted to apply this not to both the A and the B, that's fine as long as I flip the middle sign upside down. These two laws together are called De Morgan's laws. You don't need to have them memorized, but sometimes they're useful, a nice trick to have up your sleeve. And that's what's going on with part F and G. If you compare them, G, if we apply De Morgan's law and distribute the not to A and B and flip over the sign in between, look, it's the exact same expression as F. That's why we end up getting the identical sets, because De Morgan's law says that these expressions are in fact equal to one another. Okay, let's move on to part H. You might at this stage actually decide to apply De Morgan's law and say, well, this not distributes to the A not and distributes to the B. So I have A not not, flip over the sign, B not. And what's A not not? Well, a double negative, of course, just becomes a regular A. So we've got A union B not. So that's one approach. I'm going to do it a little bit differently, though. I'm going to start by first figuring out what A not is. I've got it up here, right, underlined. And I want to find out what elements it has in common with set B. That is to say, what elements appear in both A not and set B at the same time. And I can quickly see that those elements are negative 4, negative 3, and just negative 4 and negative 3, in fact, isn't it? So we've got negative 4 and negative 3. That's A not intersection B. But now I need to apply a not to the whole thing, which basically means I'm just removing negative 4 and negative 3 from the universal set. I want everything else in the universe. So let's write down the universal set, but we'll exclude negative 4 and negative 3. And I don't know if I can squeeze in my answer here, but I'll do my best. And so we've got negative 5. Remember, I'm excluding these ones because I want to take everything else, the complement. And I've got negative 2, negative 1, 0, 1, 2, 3, and 4. Alright, part I. Here's that A not not again. A double negative just brings it back to a regular old A, and we know what A is. We did that all the way back near the beginning. 0, 1, 2, 3. And lastly, part J. Again, we've got some parentheses, so let's work inside the parentheses first. A intersection B. Let's first figure out all of the elements that exist in A and B at the same time. So here's A, 0, 1, 2, 3. And here's B, negative 4, negative 3, 0, 2. The only elements that appear in both A and B are 0 and 2. So the contents of this parentheses becomes the set 0, 2. But I then want to take the not of that amount before I mix it with C. And so the not of that amount is going to be everything in the universal set except for 0 and 2. Alright, here we go then. Negative 5, negative 4, negative 3, negative 2, is negative 1. I'm taking out 0, 1. I'm taking out 2, 3, and 4. And then I also want to include the contents of C. And C is just the element of 1. Oh, no problem. It's already been included. And so I'm finished my set.